already we have covered up. Only for the newly admitted students, I'm going through all the topic of your contents from first chapter. So we started with the concept of logic gates, and these logic gates basically are used in devising logic circuit diagram, or so as to be called as the integrated chip installed in your CPU. Logic gates are basically the smallest hardware blocks which are used to comprise your integrated chips or the combinational circuit, and ultimately these are also used in comprising your sequential circuits as well. Though in sequential circuits, additionally flip-flops are being used. This is the list of all the logic gates which are used in your integrated chips, and the integrated chips basically graphically are represented by their logical circuit diagram. And these, we are saying that logic circuit diagram or your combinational circuit, or you can call it as integrated chip, is nothing but a connected series of all the gates. By default, whenever we are going to talk about the integrated circuit, presently by default we are going to talk about your combinational circuit. Presently we are going to talk about the integrated circuit of all integrated connected series of the logic gates. So we have gone through, we already have done with all the logic gates. It begins with AND gate, OR gate, inverter gate, buffer, NAND, and its functionality basically is exhibited by its truth table as well as this Boolean expression. Boolean expressions are essential, or you can call it as a Boolean algebra is essential in order to understand, in order to analyze the behavior of the logic gates. Logic gates, or eventually the logic circuit diagrams. If we talk about AND, then this is the graphical notation of the AND gate. Here two inputs are required minimally, and it will generate one output value. How it works? It works on the basis of this formula expressed in the form of the Boolean expression, and that ultimately is being exhibited by the truth table. This AND gate, if we talk about in terms of the Boolean expression, we talk about in terms of the mathematical expression. In that case, this dot operator basically represents your AND gate. And how it works? It can either be represented by this dot operator or without dot. If it is to be written, A and B are the operand or the input variables, X is the output variable, and this output variable is also called as your function, final function value. And this basically dot operator or without dot, it represents your AND gate. How it works? Whenever here we are going to talk about in terms of the binary values only. Why? Because the system understands the language of binary numbers only. Even if you are going to input some of the decimal data in the system, or you are going to write down the your programs in high level programming language or in object oriented programming language, so all the data or all the programs written in high level language or object oriented programming language eventually are being converted in terms of the machine language. Machine language is a language of zeros and ones, or we call it as the binary language. And the smallest unit of the binary language or the machine language is the bits. Bit basically represent either value 0 or 1. Means now in this chapter, as we are going to understand the internal architectural behavior of the system, internal details of the system, that's why here we are going to talk in terms of the binary values. So which binary values we are going to talk? Only two binary values essentially are there, 0 and 1. 0 and 1 are called as your bits. Now with the help of these two input variables, only two possibilities can be there. Either A can exhibit the value 0 or 1. Similarly, B can have its value as 0 or 1. So that is why whenever we are having the two variables, so how many number of combinations can be there? So with the help of the two bits, means two variables are there. So how many combinations, possible combinations can be done? It can be 2 raised to power 2. 2 represents number of variables. As many as number of variables are there. So those many, accordingly the number of combinations will be increased. Say we are having n number of variables, so number of combinations will be 2 raised to power n. So that is why here the number of combinations are 4. What are those 4 combinations? These are 0 0, 0 1, 1 0 or 1 1. If you talk in terms of the decimal value, its corresponding decimal value, that we'll study in third chapter in numbering system, how to convert all the binary values in its corresponding decimal values and vice versa. So if we talk about in its corresponding decimal value, then 0 0 will represent the decimal value as 0, 0 1 will represent the decimal value as 1, and 1 0 will represent the decimal value as 2. Similarly, 1 1 will represent the decimal value as 3. Now we come to the final function value. And here x basically represents the final value of the output, and how this value has been derived by this formula. Or you can say, whenever both values are false or whenever both values are true, 1 represents the value as true and 0 represents the value as false. When both values are true, then the result will be true, else even if at least one value is false, then result will be false. That is why specifically for the last combination, you are getting the value of the output variable as 1, and for the remaining combinations, you are getting the value as 0. So I'm not going into the details of each and every concept that already we have covered up. I have already provided you all the recorded lectures. I am only giving you a brief overview of all the concepts covered up in the first chapter. So this way the AND gate works. Similarly, this is the truth table of OR gate. Thereafter is the inverter gate. Inverter gate basically inverts. It basically negates, or it takes the ones complement of the input value. Whatever is the input value, its negation will be done. Its ones complement will be taken. 1 will be replaced by 0 and 0 will be replaced by 1. Similarly, there are the remaining gates. So those who are the newly admitted students need to listen to all the recorded lectures, go through all the contents deeply from your chapter of this book, and based on all these concepts, you have to solve all the questions of back exercise till question number 18. Now I am not covering up the remaining gates. Next topic that we have covered up is the Boolean algebra. And specifically in the Boolean algebra, we have studied these built-in Boolean identities that further will facilitate to simplify the Boolean expression. Now, from the hardware engineer point of view, how the hardware engineers are going to analyze the logical circuits or the integrated chips, how they are going to decide that how many number of chips should be there, how many number of gates are needed in order to fabricate any integrated chip. The same functionality may be achieved by a complex integrated chip as well as by the corresponding simplified version of that chip. So how to decide that from the hardware engineer's point of view, that to opt for the which kind of the integrated chip, so that it should reduce the cost as well as eventually the maintenance time as well as the cost of the engineers. So more the expression, its corresponding Boolean expression will be simplified, more there will be the reduction in number of gates in its corresponding integrated chip. So this is only the significance of studying the Boolean algebra. Like this is the Boolean expression. Corresponding to this Boolean expression, this AND gate is being designed. Similarly, if we go further for the connected series of integrated logic gates, so as to work as a independent integrated chip. For example, we have with us one example of your Boolean expression in front of us. Why we are going to call it as a Boolean? Boolean again represents the two values, either true or false. It represents the true stands for the value 1 and false stands for the value as 0. Means whatever kind of the expression we are going to talk about here, in that case, all the variables, either these are input variables or output variable, always these will occupy the value as 0 or 1. That is why we are going to specifically call it as Boolean and algebra because it's a similar kind of the mathematical algebra. Now we have in front of us a Boolean expression f is equal to x plus y dash z. If we talk about its logic circuit diagram, so how to draw its logic circuit diagram? Then we need to analyze number of input variables in it. X, Y, and Z are the input variables, and F is the output variable. So it says that, see, you can see what kind of the logical operations. We call it as now the logical operation. Logical operations will correspond to the different logical gates. This plus represents your OR gate, and in between Y dash Z there is a dot operator in the implied form that represents the AND gate, and Y dash, this dash symbol represents the inverter gate. So how many gates? By observing this expression, how many logical gates are needed in order to make a integrated chip or to make a logic circuit diagram corresponding to this Boolean expression? So one gate is this, stands for the OR gate, another inverter, and another AND. So in total, 3 gates are required in order to draw the logic circuit diagram. So how to draw the logic circuit diagram corresponding to this given Boolean expression? So we require how many number of input variables? 3 input variables, x, y, and z. So these are, simply we have to draw these 3 lines, x, y, and z. These internally, when it will correspond to the integrated chip in the CPU, then it will correspond to the number of pins. Basically, this will work as 1 pin, this will work, y will work as another pin, and this z line was another pin. And these will work as different buses to carry forward the data from one point to another, basically. So here, what kind of the input variables are there? 3 variables are there, x, y, z, and it says that y dash means one inverter gate is required in the input variable y. So this one inverter gate is being used after this in the input variable. So, and afterwards this y goes inside the inverter gate. Afterwards y dash comes out of that inverter gate, and further there is an gate applied over y dash and z. So that is why here one AND gate is being taken, in which again 2 input values are being used. One is your y dash, another is your z. The way you are going to read out your Boolean expression step by step in the similar manner, you have to go on drawing this logic circuit diagram. Means, first of all, you have to think in front of the logic operations. Logic operations will correspond to the logic gates, and you have to count number of gates required in drawing the logic circuit diagram. And parallelly, you have to identify the number of input variables, number of output variables, and very carefully you have to identify the different logical operations that will correspond to the logic gates required. Required in drawing your logic circuit diagram. And ultimately, if you view that this plus operator, which further will correspond to your or logic gate, is being used, and in which over the 2 operands, one is your x, another is your y dash. So y dash z is coming out from this AND gate, and from another side x is being coming out, and so these 2 are inputted in your OR gate, and ultimately it has resulted in the final function value f. Now, how to analyze its behavior? How to analyze the different output data in terms of the various combinations of the input values. Now, here comes up the concept of truth table. This is a truth table. Here, truth table basically represents the various values, possible values of input variables, and in correspondence to that, the resultant value of the final function variable, or rather output variable. Here we have with us the 3 variables, input variables, x, y, z. I told you that 2 raised to power n formula works in order to find out total number of combinations. And all these combinations are called as the min terms. This is the first min term, first row will termed as your first min term, then second min term, then third min term. So how many number of min terms or how many number of combinations will be there? 2 raised to power n number of combinations will be there. Here we have with us the three variables. With the help of the three variables, how many number of min terms may be generated in this truth table? 2 raised to power 3. That means 8 number of min terms can be there. So very first combination is 0 0 0. Another is 0 0 1, correspond to the decimal value as 1. 0 1 0 correspond to the decimal value as 2. 0 1 1 correspond to the decimal value as 3. 1 0 0 correspond to the decimal value as 4. 1 0 1 correspond to the decimal value as 5. 1 1 0 correspond to the decimal value as 6, and 1 1 1 correspond to the decimal value as 7. Ultimately, this value of f has been derived by this formula. Well, keep on placing the values, corresponding values of inputs in this expression. Ultimately, you will be obtaining the value of f. What was the value of x? We take one example. आपने x की value 0 डाली, then plus y dash z. Y dash will become as 0 का the complement, 1's complement of y. Y presently is 0. So 1's complement of y will be 1 and z will be 0. So 1 into 0 will be 0. Means ending of 1 and 0 will be 0. Earlier value of x was 0 and 0 plus 0. Here this plus is not the mathematical operation. It's not, does not stand for the addition operation. Rather it stands for the logical OR operations. So 0 plus 0, it says that if at least if both values are false, or at least one value, value will be 1, provided at least one value is true. But here in this case 0 plus 0 will work as your 0. So this way this value has come out, the value of the f. Similarly, you go on placing the values for the remaining combinations of specifically the input values for the remaining combinations. Ultimately, you will be getting the final value of this function variable as f. So this way, we need to understand the behavior of this logic circuit diagram. If those specific kind of the input values are injected, then ultimately what kind of the possible function value it is going to generate. So always in this chapter, basically, we focus on the simplification of the Boolean expression, and there are the two methods in order to simplify the Boolean expression. Why? What is the significance? I already have explained you. The more we simplify the Boolean expression, it will reduce the number of logic gates required in drawing the logic circuit diagram. And the functionality of, if we have the two versions of the logic circuit diagram, one is the complex one and another is the corresponding simplified version, and the functionality of both the logic gates will be same. It will be generating the same kind of the output subject to the various combinations of the input. Only the difference will be in the simplified version, there will be less number of logical gates required. So if the purpose may be solved with the help of the simplified version, why there is a need to unnecessarily increase the number of logic gates? If unnecessarily number of logic gates are enhanced, so unnecessarily it will increase its maintenance cost as well as the different other kinds of the cost. So that is the only significance to simplify the Boolean expression, so that subsequently it should be able to reduce number of gates required in drawing the logic circuit diagram. One method is to simplify the Boolean expression is to make use of built-in Boolean identities. On left hand side, these built-in Boolean identities specifically are given for OR gate, and on right hand side, all these Boolean identities are specifically given for AND gates. Very first identity says that x plus 0 will always be equal to x, and whereas the value of x can either be 0 or 1. Means for both the cases of x, whenever it is going to exhibit its value as 0 or 1, always and always this Boolean identity will remain true. At one time you can place the value of x as 0, at another time you can place the value of x as 1. In both cases you can observe that always it will come out as equal to x. X plus 0 will come out as x. Similarly, in for AND gate, it says that x into 0 will always be 0. You can take the examples of your own in order to observe the behavior of all these Boolean identities. At one time, you can place the value of x as 0. At another time, you can place the value of x as 1. Now we come to this, x plus 1 will be equal to 1. So always and always again it comes true. Similarly, x into 1 will always be equal to x. X plus x will be equal to x. X plus x in the mathematical form, if it would have been 2x, but it is not 2x here. Why? Because this plus is going to represent your OR operation, logical operation. So always x plus x will be equal to x. Means 0 plus 0 will be equal to 0 and 1 plus 1 will be equal to 1. Means 1 plus 1 means if at least one is true, result will be true. But rather in this case, both are true. So result will be x. X into x will always be x. X into x means some other, for example, one time we take 1 into 1, and another time we take 0 into 0. So 1 into 1 means both are true, result will be 1. That means true, it will be equal to x. Similarly, 0 into 0 will be equal to 0. Now we come to this. This is the commutative law. It says that x plus y will be equal to y plus x. Similarly, it stands true for the AND operation. X into y will be equal to y into x. Next is again commutative law for the three variables. X plus y plus z will be equal to x plus y plus z. Similarly, x into y plus z, y into z will be equal to xy into z. Now, specifically, these 13 Boolean identity number 13 and 14 are extremely very important. These two are required to simplify the Boolean expressions given in the back exercise. These are at most needed in simplifying the Boolean expression. So you do need to remember these two, specifically two Boolean identities, how it works. Or these two are called as your distributive laws. It says that x into y plus z will be equal to xy plus xz, and specifically the 14 Boolean identity. You have not studied earlier. It's a kind of a new identity, but it is very much important in order to simplify the Boolean expressions. It says that x plus y, it's not yx, it is yz. There is a typo mistake. X plus yz will be equal to x plus y into x plus z. So this left hand side will always be equal to right hand side. So whenever you find out in Boolean expression some kind of the sub expression, always and always you have to replace that expression in its corresponding right hand side expression. The type of the right hand side expression. Now we come to the this point number 15 and 16. Again, these two are extremely very important. These two are called as your De Morgan's law. It says that x plus y ka dash will be equivalent to x dash into y dash. This plus operator will be replaced by AND operator, and this dash that stands for the complement will individually will come to the all the variables separately. Similarly, x into y dash will be equal to x dash plus y dash. This AND gate is basically replaced by its corresponding OR gate, and this dash will individually come out to all the separately will come to the individual variables. X dash, it will come out, it will work as x dash and y dash. So these two collectively are termed as your De Morgan's law. Now entity number 17, Boolean identity, it says that x dash ka dash will be equal to x. Means if you take the complement of the complemented value, it will be equal to that value itself. All these Boolean identities are used in order to simplify the Boolean expression. This is a one example given: a b dash plus c dash d plus a b dash plus c dash d. So if you observe, then you will see that what kind of the Boolean identity is being applicable to this expression. It basically similar kind of the identity as pointed out by point 5. It says that x plus x will be equal to x. So what is x here in this case? A b dash plus c dash d is being repeated in the same expression. A b dash plus c dash d. So a b dash plus c dash d is working as x. So x plus x will be equal to x. So x plus x is here. X here is a b dash d. So this entire expression, because this a b dash plus c dash d is coming twice in this expression, so it will be equivalent to a b dash plus c dash d. So whenever you are going to simplify the Boolean expression, and you are going to use some specific kind of the Boolean identity, you within parentheses you have to mention the reason. By specifying that Boolean identity, you have applied that Boolean identity in order to simplify this expression. So within parentheses you have to specify that x plus x will be equal to x, and you have applied it over this expression. We have one more example here. F will be equal to ABC plus ABC dash plus A dash C. Now by observation, we have to see how to reduce this Boolean expression. If we observe it, then we'll view that this AB is common in first two sub-expressions. So AB can be taken common. So as and when AB is taken common, so what is left within parenthesis? C plus C dash is left, and plus A dash C, and C plus C dash will be equivalent to 1 as per the Boolean identity that earlier we have studied. So C plus C dash, earlier it was x plus x dash was equal to 1. So further, AB into 1 will be equal to AB plus A dash C. So this is the simplified version of your Boolean expression. So if you do compare these two expressions, simplified version and the earlier one, so if you count the number of gates required in the first one and required in the simplified version, so what is the difference in number of gates? In first version, how many gates were needed? One AND gate, one OR gate entirely, and AND gate 2, and then complement 3, another complement 4, one more 5, and here 1, 2, 3, 4, 5, 6. In total, 6 gates were required in this expression. Whereas the same Boolean expression, when was represented in the simplified version, only how many gates were required? One AND gate, one inverter, one AND gate, 2, 3, 4. 4 gates are required in order to draw the logic circuit diagram for this simplified version of the Boolean expression. And always we have to do remember that there may be the many versions of your Boolean functions and many versions of its corresponding logic circuit diagram, but always and always truth table will be one. Means if you draw the truth table for this complex Boolean function, and further we draw the truth table for this simplified version of this expression, always it will generate the same kind of the value of the function value corresponding to the same kind of the input combination combinations. So truth table is always unique, but the expressions, number of expressions corresponding to that, and the number of logic circuit diagrams are not unique. Sometimes you can draw the complex version of the diagram, sometimes you can draw the simplified version of the logic circuit diagram, and in a similar manner the Boolean expression also. These are some simple kind of the that customized version of the gates. It stands for OR inverter. Or invert. It is called as OR invert, or it can be called as your NOR gate as well. And this is called as invert AND. First of all, you are inverting it, and afterwards you are taking AND. And this is called as AND invert or NAND gate. First of all, you are applying AND, and afterwards you are applying inverter gate. Invert OR means first of all you are applying inverter gate, and afterwards you are applying your OR gate. All are valid. These are the two logic circuit diagram for the two versions of the Boolean expression. First one is for the complex form of the Boolean expression, and another for the simplified version of the Boolean expression. How to draw the logic circuit diagram? I told you that first of all you have to identify the possible number of input variables. आपने identify किए, फिर logic gates accordingly you have to keep on drawing, and ultimately you have to go on giving the connections as per the given Boolean expressions, and you will come up with the final logic circuit diagram. Complement of a function means here we are taking simply the complement on both sides. Here we are going to talk about the De Morgan's law specifically. I told you earlier De Morgan's law, and the De Morgan's law also work for the n number of variables. It says that कि earlier if we are having this kind of the function कि हमने complement अगर और का लिया तो whenever it is expanded, how will it be expanded? So complement will come individually to all the variables, and in between this or operator will be replaced by the and operator. And this is the another form of the De Morgan's law कि अगर आप in between and है and you have applied the complement, so how will it be expanded? Whenever it will be expanded, this and will be replaced by its corresponding or gate, and then complement will come individually all, to the all the variables. So this was the first way of first method of simplification of the Boolean expression कि आपने Boolean identities को use किया. Another method to simplify the Boolean expression is your K-map. This is called as map simplification or the Carnot map or the K-map. See, इसके लिए I already have provided you the video by taking few examples using the whiteboard option. I solved the few example, and that was more illustrative to explain the concept of the map simplification, because here the brief concepts are given in your book. So I would recommend you to go by that. It's specifically only for the newly admitted students because the remaining students already have attended the classes. So for the newly admitted students, I would recommend you to listen carefully to the recorded lecture of this K-map simplification. This is another method to simplify the Boolean expression. I'm giving you only the brief explanation. Now, I'm not going into detail step by step because details already are mentioned in that lecture. How the expression will be given in front of you. Now instead this kind of the expression may be, this is also a Boolean expression. This kind of the expression may be given in front of you. What is the meaning of that? It says that f is a function, and that is expressed in terms of the variables x, y, and z. Means there are three input variables x, y, z, and one output variable represented by f. And this expression may be represented as the summation of all the Boolean terms, all those min terms, which min terms for which the decimal value is 1, decimal value is 4, decimal value is 5 and 6 and 7, when specifically all these min terms are producing the final value of the function as 1. Whenever we are going to talk about K-map, always there are two forms of the K-map. One is your sum of product, another is a product of sum. So here by default we are going to talk about the sum of product. So this expression basically is summation of the product of all these min terms which are going to produce the final function value as 1, and these min terms, the input values of all these min terms are being represented by its corresponding decimal value as 1, 4, 5, 6, 7. Those who already have attended the classes already know this concept, and for the newly admitted students, again I would recommend to go to the recorded lecture. Now I'm only talking about the different notations. Now this K-map always is being solved by drawing this kind of a graphical diagram. It's a rectangular diagram that is being decomposed into a number of squares, and each of the square represents a specific cell. It represents the specific min term of a truth table. So what you have to do, either you will be given this kind of the expression, you will be given the truth table, or you will be given some kind of the Boolean expression. Ultimately you have to draw based on this given expression, given input expression. You have to draw this kind of the map which is called as a K-map. How many number of cells will be there, or how many number of squares will be there within this K-map, basically in this diagram, that will be dependent on number of combinations, number of min terms for that specific expression, and number of min terms will be dependent on number of input variables used in that expression. How many number of input variables are there? 3 input variables are there. With the help of the 3 input variable, how many number of min terms? 2 raised to the 3. That means 8 number of min terms will be there. So wherever there are the 3 variables, so in that K map, 8 number of min terms are being used. This correspond to that expression. This kind of the K map correspond to this expression. So here all these within the cells, here the its decimal values of the input variables are being written. And outside, above, on the borderline of this rectangle, the different input variables are represented. On one side A, on another side BC, because here we are saying three input variables. But if you view in the expression, there are x, y, z. So what kind of the notations are being used in the variable in the given expression? Those notations or those specific variables you have to make use in drawing the K map. You don't have to take new variables from your own side. So in this expression x, y, z are given, so it would be better if I think in book by mistake ABC have been used, but rather it should x, y, z should have been there, but it hardly matters. So you have to go by the expression, you have to go by the variables given in the expression. So on one side you will write down x, on another side you will write down yz or a or bc. Okay, and what will be the possible combinations of a? What possible values it can exhibit, either 0 or 1, and what possible values of bc can be there? 0 0 0 1 1 0 and 1 1. 1 0 you have written in the end, but before that you have written 1 1. I told you the reason why we have written this way, because these values have to be placed in such a manner so that in every adjacent two values, there should be a difference only at one place. I told you the meaning in the previous class कि ये एक एक प्लेस पर इसमें चेंज होना चाहिए एंड नॉट एट टू प्लेसेस. अगर हम इस 10 को पहले लिखते और 11 को बाद में लिखते, देन देयर वुड हैव बीन अ प्रॉब्लम, क्योंकि इन एडजेसेंट टू वैल्यूज में, इन दैट केस 0 1 के बाद 10 आता, उसमें एडजेसेंट टू वैल्यूज में टू प्लेसेस पे there would have been the change and that would have been wrong. So what we have to ensure कि two values have to be written in such a manner कि there should be a difference only at one place. Like 0 0 अगर करें तो it is same, but 0 is replaced by 1. Similarly, if we do compare these two values, 0 से replace होके 1 change हुआ, but 1 is same, is carry forward same in the subsequent min term, in the subsequent value. Similarly, if we do compare these two values, so 1 1 is same and 1 is replaced by 0. So this way, this consistency is maintained. Ki there is a difference only at one place in every two adjacent values. So it has to be maintained. So once all these decimal values are placed correspondingly, इनकी 1 1 जो कि min terms 1 1 produce कर रही हैं और जो zeros produce कर रही हैं, we have to substitute those values. Though it is not shown in this diagram, maybe it may come up in the next diagram. Yes, now ultimately all these have been replaced by its corresponding binary values. अब देखो ये ऊपर वाला तो नहीं, but it's a new kind of a expression, new kind of a diagram for this expression. कि this is a new expression कि f is a function in terms of a, b, c, variables a, b, c, and that is written as a summation of those min terms which are going to produce as value 1. So which min terms? 3, 4, 6, 7. So 3, 4, 6, 7 के corresponding all values are 1, 1, 1. और जो remaining min terms हैं, what are the remaining min terms? 0 बच गया, 1 बच गया, and then 5 बचा हुआ है, and then yes, 2 बचा हुआ है. तो for those min terms, like for this cell, for this cell, for this cell, for this cell, the values will be 0. अब sum of product की form में how to derive the expression कि you have to start making the group of ones, or you have to start making the group of ones in such a manner so that it should be in terms of integral power of 2. मतलब 2 का ग्रुप बनाना है, 2 के वंस का ग्रुप बनाना है, 4 के वंस का बनाना है, 8 का बनाना है. आपको इस सीरीज में बनाने हैं 1 के ग्रुप, and then by observation you have to reduce the expression and directly you can write down the simplified version of the expression. Again, I am repeating, go for the detailed video that earlier has been undertaken for this topic, and for that will work ultimately as your sum of product, the simplified version generated in the form of sum of product. And in order to find out product of sum, what you have to do, this is another form, product of sum. Product of sum ke liye what you have to do, you have to combine all zeros only, not ones. Zeros wala ye example, you have to combine those cells which are going to generate the value as 0, or you have to combine all zeros in terms of the integral power of 2, or us function ko you have to write down f dash. In place of f you have to write down f dash, and you have to write down the simply this expression by observation from this k map, and then ultimately again you have to have the complement on both sides in order to obtain the value of f. As and when you will take the complement on both sides, on right hand side you have to apply the De Morgan's law. After applying the De Morgan's law, ultimately you will be getting this kind of the expression, and this expression is called as your product of sum. So this expression is being represented in the product of sums of all these sub expressions, and this is the final product of sum form of your expression. And while talking about your K map, we discussed about don't care conditions as well. Don't care condition basically represent those kind of the min terms that make the function value either equal to 1 or 0. Means it represent those kind of the cells or those kind of the min terms for which the function value can either be 0 or 1. Like this example is given here. Other than the remaining min terms, some of the min terms or some of the cells are being working as your don't care conditions. So here this kind of the expression will be given in front of you. You will be asked to generate the Boolean expression in sum of product and product of sum form. And in batch exercise also similar kind of, you obtain the similar kind of the questions to solve. So how to interpret this expression, how to read out this expression, that you are given the function f, which is which consists of the input variables as a, b, c, and how it is to be written. It is to be read as summation of those min terms for which decimal values are 0 to 6, but which is going to produce the value of the function as 1. Means this cell also will be producing the value 1, this cell also will producing the value as 1, this 6 also will be producing the value as 1. And for these three min terms, which min terms? One min term, it also going to specify your don't care condition. Always don't care condition are basically represented by small x or d. So small x will represent d, or x will represent your don't care. And similarly, this cell also is going to represent don't care. Means this cell may produce the value as 0 or 1. Similarly, this cell 5 may produce the value as 0 or 1. And again, it's going to represent the don't care condition. And now, whichever are the missing terms, जो ऊपर वाले में भी नहीं है, नीचे वाले में नहीं है, like 4 नहीं है ऊपर नीचे, 7 नहीं है ऊपर नीचे, तो 4 and 7 will be producing the value as 0. So few min terms are going to produce value as 0, few min terms are going to produce value as 1, and few min terms are going to produce the value as don't care. Don't care means either 0 or 1, but it is not predicted, it is not firm, it is not fixed. So whenever it is not fixed, it will be represented by don't care. Don't care will facilitate to simplify more, simplify the Boolean expression further. So this is the example corresponding to that given Boolean expression. These are the three min terms which are going to produce value as 1. These three are the don't care condition, don't care cells, and other than that, these two represent the value as 0. Now, in order to produce the product of sum, Boolean expression, the product of combined in terms of integral power of 2. But wherever, if there are the adjacent don't care conditions, you have to make use of those adjacent and you have to treat it as value 1. So 1 की तरह treat करते हुए, you can go for a bigger group, you can go for a higher group. The more you are go for the higher group, it will more simplify the process. अगर 4 ग्रुप का ग्रुप बनता है, firstly you have to give the priority to priority for making the group of 4 in place of making the group of small groups of two ones. So by making use of these x's, you have made a group of 4. Now here one is unused. So again this used one may be used further in order to make a group of 1. So now we are having two groups. Based on these two groups, ultimately this function has been generated. I already have explained you how to generate this function. You can go to the previous video for that. Now we come to the combinational circuit. I told you combinational circuit is a connected series of the logic gates. This is the block diagram. There are n number of input variables. In between there is a connected series of the combinational circuit. Ultimately some kind of the output variables are being derived. There may be one output variable or there may be multiple output variables. All input variables may exhibit the value 0 or 1. Similarly, all output variables may exhibit the value as 0 or 1. Combinational circuit may not temporarily store any kind of the data. It's there only to manipulate the information. It's there only to process the information. But whenever we'll talk about the sequential circuit make use of your flip-flop as well. Sequential circuit is the connected series of combinational circuit and flip-flop. And flip-flop basically is a 1-bit storage device to store a 1 bit of information temporarily. But
Excuse me, ma'am.
yes, please.
Ma'am, what is the meaning of the statement that there are no feedback paths from output to inputs in combinational circuit?
Feedback का meaning है we are not going to talk about the timing signal here, and here whatever are the kind of output being generated at some specific timing signal that are not further used at the t plus 1th timing signal. That is not feedback means taken back, or it can be used further in case of a combinational circuit. So the same kind of one time it has done the processing, but here we are not going to talk about the clock basically that we talked about in the context of sequential circuit or flip-flop. You got the concept?
Yes, ma'am.
Okay. Now we are going to talk about your combinational circuit. Combinational circuit is only for the processing purpose, for the manipulation only. Examples of the combinational circuit we have done here. We have talked about half adder, we have talked about full adder. If you have to draw the logic circuit diagram or the combinational circuit diagram, see, logic circuit diagram and combinational circuit is one and same thing. Basically, diagram is a graphical representation of that integrated chip. That integrated chip may be called as by default as the combinational circuit. So whenever we are going to talk about the logic circuit diagram, so that means we are going to talk about your combinational circuit only. The Boolean expressions we have discussed till now, some of the few examples we have taken, those were again the connected series of your logic gates, and hence those were representing the combinational circuit only. So now the examples of the combinational circuit are half adder and full adder. So half adder के लिए अगर हमें we have to need to draw the logic circuit diagram. So first of all we need to talk about its truth table. Why? Because truth table talks about the behavior of any of the combinational circuit. It talks about here in this case the behavior of the half adder. What half adder says that it basically does the addition of 2 bits. Whenever we are going to talk about the addition of 2 bits and the addition is being performed by some of the circuit, that circuit is called as your half adder. How does it perform? Here we are having 2 input variables. What kind of possible combinations can be there? 0 0 0 1 1 0 1 1. And here 2 input variables are there. And what kind of the output being generated? Those are carry and sum. The way you do your addition manually, in a similar manner we have to think in the context of the addition manually to be done, and based on that we have to formulate the truth table. Because system is not doing of its own, the logic is feeded by the user, and logic comes from the brain of the user. So this is a user who are going to basically think of the logic, think of the problem. They are going to solve the problem manually, and ultimately, user in the sense that programmers. If you talk about the programmer are basically going to think in terms of the logic of a problem. They are going to think in, they are just think in terms of its input variables. They are going to think in terms of the output to be generated, and in between some kind of the logic is being applied in order to derive that output value. And that logic needs to be feeded in the system, so that the system should start thinking as the human beings are going to think. The system should start doing the calculation in the similar manner as a programmer or the human being do manually. So similarly here, the way we do the addition manually, bit by bit, here we are going to talk about the addition at the binary level. The way we are going to do, we are going to express in the term of the truth table, and that truth table is expressed in terms of the Boolean expression or the logic gate by some of the means by applying the K map or any other means. And ultimately we come up with this logic circuit diagram. We come up with its corresponding combinational circuit. We come up with its integrated chip need to be installed in the system, so that the way the user was doing the addition, in a similar manner the system should start doing the addition. This is the significance of learning the truth table, Boolean algebra, and eventually drawing your logic circuit diagram.
What
Fine.
is the meaning of least significant bit and the most significant bit?
What is the meaning of?
What is the meaning of least significant?
Ek minute, repeat. Please repeat your
Ma'am, what is the meaning of least significant bit
see
and most
see.
significant bit?
You have learned all the number series in your maths. Like if you talk about a number, like I talk about 278. Okay, so 278 with 2 is the most significant. 8 is the least significant bit. The bit which is having less significance in that, in framing that number, will be called as the least significant bit. Because see, 2 means 2 stands for the value as it is at hundreds place. So it will basically like 0th place, 1th place, 10th place. You have talked in terms of those numbering in the small classes numbering system. You have learned those numbering system. 2 stands for, here 2 basically its value stands for 200. Okay, so whenever the 8 is at the 1th place, so it will only the 8 number. Even if you remove that 8, we will be left with 285. I'm talking about 285 say. So last number, last value will be having its less significance. Even if you remove only 5 from 285, we will left with 280. Still there will be because it is having, even if you remove that number afterwards, even if it is having the less effect on its magnitude, then that will be called as, that digit will be called as your least significant digit. But if you remove the very first value, so entirely the number will become very small. 2 in 285, if you remove 2, 2 in the sense the 200 you are going to remove. 200 you are going to remove, you will be left with 85 only. So suddenly you will come up with a very small value. So that is why the number which is coming at the hundreds place, thousand place, that will be having more significance. You got it?
Okay, ma'am.
Okay. And now we come to the half adder, truth table of the half adder. It says that key two input variables are there. One output carry, another output is sum. I already explained you. इसके कितने possible combinations होंगे? 00011011. क्या summation दोनों को, if you do the manually summation, 00 में sum निकल के आएगा 0 and carry की value क्या होगी? 0 होगी. And 01 में अगर you do the addition, sum की value s होगी, c की value 0 होगी. If you do the addition of 1 0, value of s will be 1, value of c will be 0. If you do the addition 1 1, the 2 होगा आपका बाइनरी में 2. How the 2 is to be written? 1 0, जिसमें 0 will stand for the value s, 1 will stand for the value c. Once you are having the truth table in your hand, तो आपको you need to generate your logic circuit diagram, or you need to generate the Boolean expression. How to generate the Boolean expression and logic circuit diagram? मतलब once you are having boolean expression in your hand, so it will be very easy to generate your logic circuit diagram. But prior to that, यहाँ तक आप कैसे पहुंचे, उसके लिए you will have to apply k map. किस पे k map लगाना होगा, c पे भी वर्टिकली लगाना होगा, s पे भी लगाना होगा, मतलब इस कॉलम पे भी लगाना है, s वाले पे, c पे भी लगाना है. टू सेपरेट k map you will have to draw. फिर उसमें फिर वन वन की ज्वाइनिंग करनी होगी. वन वन की ज्वाइनिंग करते हुए s की इक्वेशन डिराइव होगी, c की इक्वेशन डिराइव होगी. दोनों को कंबाइन करके एक ही आपका सर्किट डायग्राम बनेगा. एक ही क्यों बनेगा, ड्यू टू द रीजन, क्योंकि एक्स वाई वेरिएबल्स, इनपुट वेरिएबल्स कॉमन है, एक्स वाई है, एक्स वाई है. सो अल्टीमेटली यू गेट दिस काइंड ऑफ द हाफ एडर डायग्राम. आपका देखो कहीं के मैप बना होगा, इसके कॉरेस्पॉन्डिंग नीचे जाकर यू विल गेट सम काइंड ऑफ द के मैप. ये रहा, ये आपका फुल एडर के लिए के मैप बना हुआ है. सिमिलरली यू हैव टू ड्रॉ द के मैप फॉर हाफ एडर ऑल्सो. सो दिस वे यू हैव टू जनरेट the Boolean expressions for half adder as well as the full adder. Um, First, by making use of, by applying the k map over the output variables of your truth table. And now we come to the full adder. Half adder और full adder में क्या difference है? Half adder facilitates the addition of 2 bits at a time, but full adder facilitates the addition of 3 bits at a time. So here we are, if you talk about its truth table, so here we have 3 variables. What kinds of the combinations can be there? 8 combinations can be there again. These are the 8, 0 to 7 in decimal. So these are 8 combinations. And what are the output variables? Values. One is carry, another is summation. The way you are doing manually addition, that addition you have to specify, you have to express in terms of the truth table. तो अगर if you do the addition of these 3 bits, इन तीनों का एडिशन करते हैं 0 + 0 + 0, तो आपका सम क्या आएगा, 0 आएगा, एंड कैरी क्या आएगी, 0 आएगी. सिमिलरली इफ यू डू द एडिशन ऑफ 0 + 0 + 1, सम क्या आएगा, 1 आएगा, कैरी क्या आएगी, 0 आएगी, एंड सो ऑन. यू हैव टू कीप ऑन डूइंग एडिशन. सिमिलरली लास्ट में 1 + 1 + 1 आपका डेसिमल में 3 हुआ, और बाइनरी में कैसे लिखा जाएगा, 1 1. तो सम क्या आएगा, 1 आएगा, कैरी क्या आएगी, 1 आएगी. Once you have obtained the truth table, ultimately you need to generate Boolean expressions. And how to generate Boolean expression? You have to draw k map over C. Similarly, you have to draw k map over S. So k map draw करने के बाद these kind of the k maps you have drawn, ultimately you will get this kind of the expression. C and S के लिए you got this kind of the expression. And ultimately you have drawn this kind of your diagram. One main point I told you in the previous slides as well, कि आपने यहाँ 1 1 का एक ग्रुप बना सकते थे इस C के लिए, इस K मैप में, but you have not made, though that would also be correct, would have been correct, that combinations also, but you have not made it, you have made it like that कि आपने ये इसको इंडिपेंडेंटली छोड़ दिया, ड्यू टू द रीजन आपका मोटिव था कि आप इस टाइप का डायग्राम ऑब्टेन करें. इस टाइप का कैसे, कि आप एक्सक्लूसिव और की फॉर्म में करें. वाई, बिकॉज कि आपका जो हाफ एडर का डायग्राम है उसमें एक्सक्लूसिव और ही आपका आ रहा है. देखो आपका हाफ एडर का डायग्राम क्या था, ये आपका एक एक्सक्लूसिव और गेट था और एक एंड गेट था. नाउ इफ यू ऑब्जर्व द लॉजिक डायग्राम ऑफ फुल एडर, यहाँ पर भी एक एक्सक्लूसिव और एक एंड गेट, एक एक्सक्लूसिव और एक एंड गेट, मींस ये वन, दिस इज वर्किंग एज वन फुल हाफ एडर, वन हाफ एडर, this is another half adder, and this full adder is the connected series of 2 half adders. So sometimes it is feasible with that hardware engineers are having with them the 2 integrated chips of 2 half adders. So straightforward, by joining 2 half adder, they can comprise one circuit diagram for your full adder. This is the significance only, कि आपका इस वे में भी ऑब्टेन हो सकता है आपका फुल एडर का डायग्राम. फुल एडर डायग्राम में भी एक्सप्रेस्ड इन टर्म्स ऑफ द कनेक्टेड सीरीज ऑफ 2 हाफ एडर्स. तो आपने 2 के मैप लगा के जनरेट किया, एक एस के लिए एक्सप्रेशन, एक सी के लिए, एंड अल्टीमेटली यू हैव ड्रॉन द लॉजिक सर्किट डायग्राम, एंड दिस वे you have come up with your logic circuit diagrams of half adder and full adder. In exams you can get this kind of the question that define the combinational circuit, give one example, and specifically if it is asked in the context of full adder, half adder, you will have to give the definition of half adder. You will be asked to give draw the logic circuit diagram, its truth table, and obtain its Boolean expressions for half adder and full adder. Sometimes you may be asked to obtain the logic circuit diagram of full adder as a connected series of two half adders. So this way, this will work. This entire calculation will work. Now we come to the last topic, that is your flip flop. Though already we have covered up. Flip flop, I told you, it's a binary cell capable of storing one bit of information at a time. Temporarily means the data which is being stored in one cell. One bit of information is being cell that may be reused during the next timing signal. I told you that whenever we are going to talk about the flip flop, always and always we talk about in the context of the clock. Here was some symbolic diagram of the clock. This is a symbolic diagram of clock. I told you basically it is a basically it's a signal, kind of a signal that represent the clock. Sometimes current is on, sometimes current is off. Basically current is passed on, and whenever there is a current, that value will represent the high state. Whenever current is not there, it will represent as the low state or the low transition, negative transition. This will be called as a negative transition. This will be called as the positive transition. It will represent the value as 1 or high state. It will represent the value as 0 or low state. And this is called as your rising edge. This is called as a falling edge. This is rising edge, falling edge, and the flip flop will remain activated or functional during the high state or during the time when value of clock is enabled. It is enabled. This is disabled. Whenever there is a current, then it is enabled. Whenever there is not a current, then it is disabled. Whenever as and when the current comes, I gave you the example कि जैसे ही हम switch on करते हैं आपका fan on हो जाता है. तो fan is a kind of a flip flop that is associated with some kind of the triggering activity. Triggering activity आपका button है. As and when it is activated, it is on, automatically it will trigger to the activity of your fan. Similarly, your flip flop is associated with the current flowing in the specific switch. As and when the current is there, as and when it is in one state, it is high state, or you can call it as the during the positive transition, it is high, and during that time, so far as it will remain high, that flip flop will remain activated. When will it triggered? It will be triggered when clock is enabled. Generally, we it's not every time essential that कि आप flip flop को सिर्फ हाई पॉजिटिव ट्रांजिशन के साथ एसोसिएट करें. समटाइम्स दे मे बी कस्टमाइज कि आप ऑन तब भी हो सकता है व्हेनेवर इट इज स्विचिंग फ्रॉम लो टू हाई. जब लो टू हाई राइजिंग एज के साथ आपके कोई फ्लिप फ्लॉप को एसोसिएट किया जाएगा, तो उस टाइप के फ्लिप फ्लॉप को क्या कहा जाएगा? उस टाइप के फ्लिप फ्लॉप को कहा जाएगा एज ट्रिगर्ड फ्लिप फ्लॉप. मतलब जो फ्लिप फ्लॉप ट्रिगर हो रहे हैं, एक्टिवेट हो रहे हैं with respect to the rising edge or falling edge, those kind of the flip flops are specifically called as the edge triggered flip flops. Only definite. Yes, please.
Ma'am, out of negative and positive edge triggered, which is more preferable?
देखो, it's not the matter of preferable. It all depends on the designing of the circuit. ओके आपका ये तो आपके कस्टमाइजेशन पे है कि आपका फ्रेम कैसे किया गया है. बाय डिफॉल्ट जो एक ट्रेंड सा है वो ट्रेंड है आपका ट्रेंड पॉजिटिव ट्रांजिशन के साथ. जनरली आपके जो मोस्ट ऑफ द फ्लिप फ्लॉप्स आर बीइंग यूज्ड, बट इन रेयर केसेस सम ऑफ द फ्लिप फ्लॉप्स आपके पॉजिटिव ट्रांजिशन के साथ किए जाते हैं. बट देयर इज अ प्रोविजन ऑल्सो कि आपका लोअर ट्रांजिशन के साथ भी किया जा सके, आपके फॉलिंग एज के साथ भी किया जा सके. ओके, सो वो तो इट हार्डली मैटर्स. Everything is basically dependent in terms of the optimization, in terms of your time and cost. आपकी टाइम किसमें ज्यादा लग रहा है, कॉस्ट ज्यादा लग रहा है, तो इसमें इट्स नॉट अ मैटर ऑफ टाइम और कॉस्ट. ओके, बट इट इज नॉट इन ट्रेंड बिकॉज इट्स एन easier use of associating the flip flop with the positive transition only. Generally it is to be done. Conventionally आपका क्या चल रहा है? Conventionally आपका positive transition के साथ ही triggering का concept चल रहा है. Okay. Now we come to the, again we revert back to the flip flop. Flip flop essentially are divided in four forms. One is your SR flip flop, another is your JK flip flop, another is your this is your D flip flop, another is your JK flip flop, another is your T flip flop. Though I already have explained all these concepts in the previous lecture in detailed manner. I'm going through all these concepts कि आपका SR flip flop कैसे काम करता है. This is the graphical notation of your SR flip flop. Two input values are there termed as your SNR, and clock is also there in order to enable, in order to trigger this flip flop. As and when it is enabled, it is value of clock is 1, then only this flip flop will be triggered, it will start working. And what output values are there? Q and Q dash, this will represent as complemented value, will represent as Q dash. And here in this context, we this kind of the table is called as a characteristic table. Earlier we talked about the truth table. Here only the name is difference, otherwise it also exhibits the behavior of your flip flop, respective flip flop. But here, what is the difference? Essentially, we talk about in terms of the timing signal. I told you in the context of the clock that it is called as your negative transition. It is called as your positive transition. So, beginning from this negative till positive, this till this point, it is called as one timing signal. Similarly, again, it is lower transition, it is high transition, positive transition, and beginning from this point to next this point is called as a next timing signal. So the flip flop, which is has generated some of the value at tth timing signal, that may be reused as the input value in order to generate the subsequent output value at t plus 1th timing signal. So here we are going to observe the behavior of the next output variable in the next timing signal with respect to the previous output variable. So again, I'm repeating, flip flop के case में with the help of the characteristic table, what actually we are doing, we are observing the behavior of the output variable generated at t plus 1th timing signal with respect to the output generated previously at the tth timing signal. I go back to the characteristic table. See, what we are observing? We are observing the behavior of the output variable Q, which is being generated at t plus 1th timing signal, but we are analyzing its behavior in the context of previously generated output variable at tth timing signal. So what this characteristic table says? It says that, and all that behavior depends with respect to the different kind of the combinations of the input variable. Input variable आपके क्या क्या थे? I go back to the SR flip flop. देखो इनपुट वेरिएबल क्या क्या थे एसआर में 0 0 के अगेंस्ट इट सेज दैट कि अगर एसआर की वैल्यू इनपुट वेरिएबल की वैल्यू 0 0 फिक्स कर दें तो ऑलवेज एंड ऑलवेज क्यू टी प्लस की वैल्यू प्रीवियस वाले आउटपुट के इक्विवेलेंट ही जनरेट होगी. ऑलवेज एंड ऑलवेज मतलब हर बार आउटपुट जो होगा नो चेंज. एक बार जो बिगनिंग वाला आउटपुट जो फिक्स हो गया वही का वही आगे जनरेट होता चला जाएगा. मीन्स अगर QT की वैल्यू 0 थी तो QT प्लस 1 भी 0 ही होगा. QT की वैल्यू 1 थी तो QT प्लस 1 भी 1 ही होगा. नाउ वी कम टू द सेकंड कॉम्बिनेशन कि अगर SR की वैल्यू 0 1 है, इट सेज दैट द QT प्लस 1 ऑलवेज will be equal to 0. It is also called as clear to 0 irrespective of the previously generated output value. मतलब it is not dependent on the previously generated output value at the tth timing signal. It will always generate the value as 0 provided the corresponding combination of SR is 0 1. Okay, now whenever value of SR is 1 0, then Q of T plus 1, that is the output generated at T plus 1th timing signal, always and always will be 1, which is also termed as set to 1 irrespective of the previously generated value of QT. It is not dependent on the previously generated value of QT. Now we come to the next combination, that is your 1 1. It says that whenever it's
Excuse me, ma'am.
yes,
मैम
Yes, please.
ये जो यहाँ पे ये सेट रीसेट है, इससे बेसिकली इसका क्या सिग्निफिकेंस है मैम?
It
क्यूटी
is
इनपुट ही है हमारे पास, तो हमें जरूरत क्या है इनकी?
Qt is not the input. Qt is the output variable.
तो
Okay.
मैम फिर ये सिग्निफिकेंस क्या है इसका यहाँ पे, लाइक?
बेटा बता तो रही हूँ आपके लॉजिक। अच्छा, एंड गेट कैसे बिहेव कर रहा था आपका, बताओ कैसे कर रहा था, प्लीज एक्सप्लेन। उसकी ट्रुथ टेबल का क्या मीनिंग था एंड के केस
मैम कि
कंटेक्ट?
मतलब अगर एक भी जीरो हो गया तो बाकी आगे वो जाएगा ही नहीं, वो आगे जीरो ही रहेगा।
जाएगा नहीं मतलब उसके आउटपुट की वैल्यू जीरो आएगी।
जीरो वन इज जीरो,
है,
जीरो वन इज जीरो।
हाँ, 0 1 is 0 और 0 1 is 0, 0 1 क्या थे इनपुट वेरिएबल्स, और जो रिजल्टेंट आया वो क्या था आउटपुट वेरिएबल, इजंट इट? यही था ना। तो ट्रुथ टेबल आपका क्या एग्जिबिट कर रहा था, उसका बिहेवियर कर रहा था कि अगर इनपुट का ये कॉम्बिनेशन है तो आउटपुट ये जनरेट होके आएगा। लेकिन फ्लिप फ्लॉप में आई टोल्ड यू कि यहाँ पर हम टाइमिंग सिग्नल की बात कर रहे हैं, क्योंकि आपका जो आउटपुट जनरेट होके आया वो आपका कैरी फॉरवर्ड नेक्स्ट वाले टाइमिंग सिग्नल के आउटपुट के लिए रीयूज हो सकता है। that value may be reused, sometimes it may be reused, sometimes it may not be reused. Okay, तो ये आपका built in flip flops है. These already have been designed by the hardware engineers. We are not designing, it's not in our hand कि हमें इसकी टेबल कैसे बनानी है, ये आपकी built in टेबल है।
मैम
Yes please.
मैम जैसे मैम एंड गेट है मैम, उसका एक यूज है, मतलब वो एक फंक्शन परफॉर्म कर रहा है, जैसे मल्टीप्लिकेशन परफॉर्म कर रहा है, और गेट भी एडिशन परफॉर्म कर रहे हैं, तो मैम फ्लिप
Exactly.
फ्लॉप मैम ये एसआर जो जी की क्या परफॉर्म कर रहे हैं?
देखो बेटा, ये आपका फर्दर सीक्वेंशियल सर्किट कॉम्प्राइज करने के लिए यूज होते हैं। दीज आर द स्मॉलेस्ट यूनिट ऑफ योर सीक्वेंशियल सर्किट। आई टोल्ड यू द डिफरेंस इन कॉम्बिनेशनल सर्किट एंड सीक्वेंशियल सर्किट। कॉम्बिनेशनल सर्किट क्या है, सिर्फ कनेक्टेड सीरीज ऑफ आपके लॉजिक गेट्स हैं। बट इफ यू गो फर्दर एट द एंड ऑफ दिस चैप्टर यू विल व्यू द कॉन्सेप्ट ऑफ सीक्वेंशियल सर्किट इन डिटेल। फॉर एग्जाम्पल, सीक्वेंशियल सर्किट आपके क्या है, इट्स अ कनेक्टेड सीरीज ऑफ योर कॉम्बिनेशनल सर्किट एंड फ्लिप फ्लॉप। कॉम्बिनेशनल सर्किट इटसेल्फ लॉजिक सर्किट्स की कनेक्टेड सीरीज है, एंड फ्लिप फ्लॉप। और फ्लिप फ्लॉप से कुछ जनरेट हुआ तो ये आउटपुट रिटेन हो सकता है, बिकॉज फ्लिप फ्लॉप आपका बाइनरी सेल है। इट में डेटा में बी कैरी फॉरवर्ड to the next for the next manipulation, for the next processing. Either further it may be used as a input value sometimes. आपका फ्लिप फ्लॉप कहाँ यूज हो रहा है, अगेन ये आपकी चिप्स बनाने में यूज हो रहे हैं। अब चिप किस लिए बनाने में यूज हो रहे हैं, किस टाइप की चिप्स, इसका एक एग्जांपल है। वैसे आपका एक सॉल्व एग्जांपल इस सीक्वेंशियल सर्किट का है, दो इट इज नॉट इन योर कोर्स। इफ यू वांट टू डू यू कैन गो थ्रू ऑफ योर ओन कि सीक्वेंशियल सर्किट कैसे बना। बनते 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 ये एक चिप बन के आ गई है। ये चिप बन के ऐसी लुक आ रही है जो क्या फंक्शनैलिटी कर रही है, जिसकी फंक्शनैलिटी इन इक्वेशंस के थ्रू डिपिक्ट हो रही है। और अल्टीमेटली you will view the example of the sequential circuit here is given as binary counter. ये देखो, whenever we talk in terms of the sequential circuit always we talk about its state table. तब हम we don't talk about the characteristic table, we don't talk about your truth table. Here the table that we draw is called as a state table. Here the diagram that we draw is called as state diagram. So ये आपका क्या है, यहाँ पर आगे आपके
मैम ये सिलेबस में है?
no, you don't have your in your syllabus, and that's why I have not covered up in your in the lecture.
Okay.
Okay, this is the additional portion. Similarly, this is a binary counter. Binary counter again is a chip जो क्या जनरेट करता है, आपकी बाइनरी वैल्यूज को करता है, जो फर्दर आर यूज्ड इन सम काइंड ऑफ द एप्लीकेशंस. ओके, all these are the examples. 2-bit binary counter. So 2-bit binary counter is comprised with the help of is as a interconnected series of logic gates and flip flop. Okay, so flip flop का ये यूज है कि फर्दर आपकी इंटीग्रेटेड चिप्स बन रही है, चिप्स बन रही है एज पर द रिक्वायरमेंट and for some specific application. So now I am going back to the flip flop. So we are going to study the built-in kind of the flip flops. We are going to study its behavior only. Okay, so this table cannot be customized by us. So SR flip flop के case में we are studying its output value generated at t+1th timing signal कि ये कैसे बिहेव करेगा, ये जो आउटपुट जनरेट होगा, जो नेक्स्ट आउटपुट जनरेट होगा उसका बिहेवियर कैसे डिटरमिन होगा. इट विल बी डिटरमिन्ड बाय द specific input, specific type of input combination. Is that clear now? and whenever value of SR is 1 1, in that case it is not predetermined, it is not fixed, behavior is not fixed, because it randomly works. Sometimes it generates the value as 0, sometimes it generates as value 1. इसके सिमुलेटर और इसके सैंपल्स बना के, प्रोटोटाइप्स बना के अगर इंजीनियर्स देखें, इस चिप को चला के देखें, उसे सिमुलेट करें, so it always the value cannot be fixed, it cannot be predicted, and that is why they have put a question mark in front of it. They have called this state as an indeterminate state, कि they cannot decide that which kind of the value, they cannot take a firm decision कि whether it will generate always and always 0 value or 1 value. Clear? So this is the, yes please.
मैम जैसे लास्ट क्लास में हमने पढ़ा था, जैसे करेक्टर एक्सपेंडेड करेक्टर टेबल पढ़ी थी हमने हर फ्लिप फ्लॉप की।
एक्सपेंडेड नहीं, एक्साइटेशन टेबल।
नहीं मैम, जो जिसके अंदर हमने एसआर की दो वैल्यूज ली थी, उसके लिए कॉरेस्पॉन्डिंग क्यूटी की दो वैल्यू ली थी।
यस 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 यस, हाँ प्लीज।
हाँ, तो मैम जैसे यहाँ पर इसके अंदर हर एसआर के कॉम्बिनेशन के लिए जैसे पहला क्यूटी आ रहा है, फिर 0 आ रहा है, फिर 1 आ रहा है, और फिर क्वेश्चन मार्क आ रहा है।
एग्जैक्टली।
तो हमने जो टेबल में पढ़ा था उसमें हमने हर कॉम्बिनेशन के लिए दोनों वैल्यू से किया था, 0 1 0 1 0 1, और क्वेश्चन मार्क के लिए भी 0 1 से किया था।
एग्जैक्टली।
हाँ, तो मैम जैसे यहाँ पे क्वेश्चन मार्क है तो फिर भी 0 1 हो रहा है, और ऊपर अगर 0 लिखा है तब भी हम दोनों ले रहे हैं, और 1 लिखा है तब भी हम दोनों ले रहे हैं, ऐसा क्यों?
एक मिनट आप बेटा इसे एक बार आप इसे समझने की कोशिश करो ना, आप इसे कैसे रीड करोगे? देखो, हम आउटपुट QT + 1 की बात कर रहे हैं, हमने QT के लिए लिखा था, QT था प्रीवियस आउटपुट वैल्यू, QT के लिए हमने 0 1 0 1 डाला था। सो व्हाट वी आर सेइंग फॉर QT + 1, QT + 1 के लिए हम क्या बोल रहे हैं कि इसकी वैल्यू अगर SR की वैल्यू 0 0 है तो इसकी वैल्यू नो चेंज होगी QT। हमें यहाँ QT की क्या पॉसिबिलिटी थी, या 0 या 1, राइट? तो 0 थी तो 0 आया, 1 थी तो 1 आया, ये क्लियर है?
यस मैम।
अब हम आए नेक्स्ट पे हम कह रहे हैं कि QT + 1 की वैल्यू हमेशा 0 ही निकल के आएगी, प्रोवाइडेड SR की वैल्यू 0 1 है। अब यहाँ कह रहे हैं कि QT प्रीवियस वाला आउटपुट क्या हो सकता था, प्रीवियस वाला आउटपुट 0, प्रीवियस वाला आउटपुट या 0 हो सकता था या 1 हो सकता था, बट वी आर नॉट कंसर्न विद दैट। क्यों? क्योंकि आपके जो आउटपुट निकल के आया, इट इज नॉट डिपेंडेंट ऑन द प्रीवियस वैल्यू ऑफ आउटपुट। ये फिक्स की हुई है हार्डवेयर इंजीनियर्स ने कि इसकी वैल्यू हमेशा 0 ही होगी। किसकी वैल्यू? नेक्स्ट आउटपुट, दिस इज द नेक्स्ट आउटपुट वैल्यू। लेकिन irrespective, I am using the word irrespective of the value of the previous output, तो मतलब previous output 0 था या 1 था, we are not concerned with that value। वो 0 भी हो सकता था, 1 भी हो सकता था, it hardly matters, लेकिन QT + 1 हमेशा 0 निकल के आएगा, प्रोवाइडेड SR की वैल्यू 0 1 आ रही है। यस, एंड सिमिलरली QT + 1 की वैल्यू 1 होगी, प्रोवाइडेड SR की वैल्यू 1 0 है। उसमें QT कहीं रोल में नहीं आता, लेकिन उसकी वैल्यू कोई ना कोई तो जनरेट हुई थी प्रीवियसली, या 0 जनरेट हुई थी या 1 हुई थी, इसलिए हमने दोनों पॉसिबिलिटी लिख ली थी। सिमिलरली फॉर SR, अगर इसकी वैल्यू 1 1 है, QT हम नेक्स्ट आउटपुट की वैल्यू बात करें जो टाइटल में लिखा है, टाइटल की ही वैल्यूज नीचे जा रही हैं, तो टाइटल में क्या आपका QT + 1 जो फील्ड का नाम है, तो इसकी वैल्यू कैन नॉट बी डिटरमिन्ड, इट कैन नॉट बी फिक्स्ड, इट कैन नॉट बी डिराइव्ड, लेकिन उससे प्रीवियस वैल्यू तो 0 भी हो सकती थी और 1 भी हो सकती थी, इसलिए हमने एक्सपेंडेड टेबल के अंदर दोनों पॉसिबिलिटीज लिखी थी in order to better understand the concepts. Is that clear now? Should I proceed further?
Yes मैम। और मैम यही रीजन है जो ये जो हमारा एब्स्ट्रैक्ट डायग्राम है उसके अंदर जो आउटपुट है यानी ये Q वाला, उसके अंदर Q और Q0 दोनों दे रखे हैं।
Q0 हमने इसलिए मैंने आपको इसका एक लॉजिक सर्किट डायग्राम दिखाया था इंटरनल, वहाँ Q0 ओके, वो क्योंकि फ्लिप फ्लॉप का जो आउटपुट जनरेट होता है वो ये वैल्यूज निकल के कैसे आ रही हैं आपकी कैरेक्टरिस्टिक टेबल में, ये वैल्यू किसी ना किसी लॉजिक के थ्रू आ रही है, कोई ना कोई अंदर इंटीग्रेटेड चिप बनी हुई है, उस चिप का डायग्राम मैंने दिया था कि उसमें Q' भी कहीं रोल में आ रहा है, Q' को एज द इनपुट वैल्यू नेक्स्ट टाइम यूज किया जा रहा है और फर्दर रिजल्ट्स को डिराइव करने में हेल्प करा रहा है, इसलिए एक Q के अलावा इंटरमीडिएटली Q' भी निकल के आता है। और अगर हम जेके फ्लिप फ्लॉप में कहेंगे की बात करेंगे तो जेके फ्लिप फ्लॉप में ये जो ओवरकम हो रही है आपकी प्रॉब्लम, ये तब Q' आपका फाइनल आउटपुट निकल के आता है इनडिटरमिनेट स्टेट के रिप्लेसमेंट में। Okay.
Yes,
So
ma'am. Okay, thank you.
okay, now I am coming with the JK flip flop immediately. That earlier was the shortcoming of your SR flip flop. ये इसकी shortcoming थी कि एक fixed value provide नहीं कर सकता SR flip flop. But the later on the hardware engineers found a solution for this value as well. उन्होंने इसे enhanced version इसका लाए. इसका enhanced version was called as your JK flip flop, जिसमें it was overcome this problem was overcome in the characteristic table of JK. इसमें JK में remaining values are same. It will behave exactly in a similar fashion as SR flip flop is working, except the last row में क्या था इसमें कि अगर 1 1 है JK की वैल्यू, ऑलवेज एंड ऑलवेज जो आउटपुट QT प्लस 1 निकल के आएगा वो प्रीवियस आउटपुट वैल्यू की कॉम्प्लीमेंटेड वैल्यू आएगी. प्रीवियस वैल्यू
मैम
हमारा Q.
मैम इसका मतलब कि उन्होंने जो अंदर लॉजिक सर्किट डायग्राम है उसमें कुछ चेंजेस किए होंगे ना?
ऑफ कोर्स यस, उसमें चेंजेस किए हैं, उसके अंदर कुछ नया लॉजिक लगाया है, इनपुट आउटपुट में चेंजेस किए हैं, लॉजिक गेट्स और फ्लिप फ्लॉप में चेंज किया, उनकी कनेक्टेड सीरीज में चेंज किया इन ऑर्डर टू ऑब्टेन सच काइंड ऑफ द आउटपुट, सच काइंड ऑफ द ओके. सो ओके, नाउ तो इसका क्या कॉम्प्लीमेंटेड वैल्यू हैज बीन ऑब्टेन्ड corresponding to the combination 1 1 as the value of JK. Now we come to D. D कैसे वर्क कर रहा है? I told you earlier कि जो इनपुट जाता है वही आउटपुट निकल के आता है. Only single input variable is there and single output variable is there. जो इनपुट गया वही आउटपुट आया, जो इनपुट गया वही आया. 0 0 0 इनपुट गया. और ये बेसिकली अगर SR फ्लिप फ्लॉप की बात करें, SR फ्लिप फ्लॉप की बात करें तो उस केस में बेसिकली आपके जो बीच की 2 रोज हैं, just hold on for a moment. Yes, please. We were talking about flip flop, specifically the D flip flop. अगर हम SR में आते हैं तो D flip flop आपके बीच की 2 rows rather specifically, अगर इसको R की, because in D only one input variable is there, तो आप बीच की specifically if you observe the 2 rows of this SR flip flop, तो उसमें आप देखेंगे कि S में अगर 0 इनपुट जा रहा है आउटपुट भी 0 निकल के आ रहा है. सिर्फ S की बात करें 1 इनपुट जा रहा है तो 1 ही निकल के आ रहा है. सो SR टेबल से SR flip flop से somehow by making some kind of the changes D flip flop may be comprised. तो sometimes in back exercise आपका कुछ reframe करके क्वेश्चन आ सकता है SR flip flop से how can you extract the D flip flop. उसमें कुछ इन्वर्टर लगाकर या उसका एज ए इनपुट वैल्यू को कहीं डाइवर्ट करके यू कैन कस्टमाइज द SR फ्लिप फ्लॉप इन ऑर्डर टू वर्क जस्ट लाइक एज योर D फ्लिप फ्लॉप, कि सिर्फ बीच के 2 रोज के अंदर S के इनपुट को यूज करते हुए अल्टीमेटली यू आर बीइंग एबल टू डिराइव द आउटपुट वैल्यू एज 0. आई एम कमिंग बैक टू D फ्लिप फ्लॉप. D फ्लिप फ्लॉप आपकी ग्राफिकल नोटेशन ये है, जो इनपुट गया वही आउटपुट निकल के आया, बट इंटरमीडिएट आउटपुट आपका कॉम्प्लीमेंट भी रहेगा. ये क्या कह रहा है कि जो 0 गया तो इट विल बी आउटपुट वैल्यू विल बी नेक्स्ट आउटपुट वैल्यू विल बी 0, एंड सिमिलरली 1 इज अगर इनपुट वैल्यू है तो नेक्स्ट आउटपुट वैल्यू विल बी 1. और 0 को कहते हैं क्लियर टू 0 और 1 को कहते हैं सेट टू 1. सो फॉर्मूला इसका क्या होगा? QT प्लस 1, बिकॉज आउटपुट आपका QT प्लस 1 है, विल बी इक्वल टू D. D मीन्स जो इनपुट जा रहा है वही आउटपुट वैल्यू इक्वेट हो रही है आपकी. नाउ वी कम टू द T फ्लिप फ्लॉप. T फ्लिप फ्लॉप कैसे वर्क करता है? इसमें भी सिंगल इनपुट है और आपका आउटपुट Q है, बट इंटरमीडिएट आउटपुट कॉम्प्लीमेंट है. अगर 0 जाता है तो आउटपुट है नो चेंज, 1 है तो नीचे कॉम्प्लीमेंट. मीन्स इफ यू गो बैक टू द JK फ्लिप फ्लॉप और उसके फर्स्ट वाली रो को ऑब्जर्व करें और लास्ट वाली रो को ऑब्जर्व करें, तो फर्स्ट वाली रो और लास्ट वाली रो को यूज करते हुए दिस टी फ्लिप फ्लॉप में बी कॉम्प्राइज्ड, में बी डिवाइज्ड। इसमें करें तो जे की वैल्यू 0 थी तो ये नो चेंज था, जे की वैल्यू 1 है तो क्यू डैश टी। सिमिलरली टी की वैल्यू 0 है तो नो चेंज, टी की वैल्यू 1 है तो ये कॉम्प्लीमेंट। सो दिस वे basically you are studying the concept of all the kinds of the flip flop. Now I am coming to, अच्छा वन लाइन डेफिनेशन आपकी मास्टर स्लेव फ्लिप फ्लॉप की भी है। मास्टर स्लेव फ्लिप फ्लॉप ओनली वन डेफिनेशन इज देयर। Another type of flip flop used in some systems is the master slave flip flop. This type of circuit consists of two flip flops. The first is called as the master, which respond to the positive level of the clock, and the second is the slave, which respond to the negative level of the clock. Uh, इट इज द कनेक्टेड सीरीज ऑफ टू फ्लिप फ्लॉप है। जो आपका फर्स्ट जो फ्लिप फ्लॉप है जो आपका राइजिंग एज के साथ एक्टिवेट हो रहा है, ट्रिगर हो रहा है, और स्लेव जो जिसे आप कह रहे हैं दूसरे वाला वो आपका नेगेटिव ट्रांजिशन राइजिंग। एक मिनट, लेट मी रीड इट अगेन। The first is the master which responds to the positive level. Positive level means this positive transition, and another basically the second is the slave which respond to the negative level. Negative level means this is the negative level. So one is going to respond with the positive level, positive transition, another is going to respond to the negative transition. But these are not in trend, these kind of the flip flops. These earlier were used, but now these are not trend. So you have to do only the definition of this flip flop. Now we come to the excitation table. Excitation table, again I told you, is the reversal of your characteristic table. It may be obtained with the help of the characteristic table. I explained the concept of excitation table in the previous lecture. You refer to the previous lecture in order to obtain or understand the concept of excitation table. कैसे हमने excitation table निकाली थी, I am not going into its detail. कि आपके पास अगर आउटपुट वेरिएबल, you begin with आउटपुट वेरिएबल, आपके पॉसिबल कॉम्बिनेशंस क्या होंगे 0 0 0 1 1 0 1 1। अगर आउटपुट आपके ये हैं तो पॉसिबली आपके क्या इनपुट हो सकते हैं एस आर। आई एम नॉट गोइंग इनटू इट्स डिटेल्स, यू रेफर टू द, अगेन आई रिपीट, रेफर टू द प्रीवियसली रिकॉर्डेड लेक्चर in order to understand the concept of excitation table. Now sequential circuit की brief definition I already have explained that it is a connected series of combinational circuit and flip flop, and if some output is being generated that may be reused as the input value. Till this phase you do have in your course. Afterwards the remaining portion of this chapter you don't have in your course. Now we directly come to the back exercise. Back exercise में you have solved all the questions beginning from very first. We have discussed all these questions. I am not going into the details of all these questions which already we have discussed. And for the newly admitted students, I would suggest you to refer to the previously recorded videos. There we had the discussion regarding the solution of all these problems. Till we already have discussed till question number 13. Now we come to question number 14. Using table 1 to derive the Boolean expression for the sum output of the full adder in sum of product form, then by algebraic manipulation show that S can be expressed as exclusive of or of the three input variables. This is the same problem as of the full adder. Full adder problem we already is solved in the chapter okay, so we already have done with this full adder. So you refer to the solved portion of your chapter that we already have discussed. Now we come to question number 15 and 16. What is the statement of question number 15? A majority function is generated in a combinational circuit when the output is equal to 1. If the input variables have more ones than zeros, the output is 0. Otherwise, design a 3-input majority function and draw the logic circuit diagram as well. It may be asked. Means you are given a problem. Based on this problem, you have to obtain its Boolean function as well as you have to draw the logic circuit diagram. You have been given some kind of the hint in order to frame the truth table. Once you are being able to obtain the truth table, it will be easier to apply K-map And once you apply the K-map, ultimately you will be able to get the simplified version of the Boolean function. Once you get the simplified version of the Boolean function, it will be easier for you to draw the corresponding logic circuit diagram. Here I am going to show its solution, and I am going to explain the concept. It's question number 15. I'm going to explain you how by understanding the hints given in the problem, how the truth table has been framed. Once you are being able to frame the truth table, the question will be easier to solve. What was the statement? It says that a majority function is generated in a combinational circuit when the output is equal to 1. If the input variables have more ones than zeros, the output is 0. Otherwise, design a 3-input majority function. So first of all, how many input variables are given? 3 input variables are given. So with the help of the 3 input variables, how many combinations can be there? 8 combinations can be there. What are the possible values? 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1. You have to list out all the possible combinations of those input variables. Now, which value of f we are going to obtain? The mention is there in the given problem. What is the logic specified in the given problem? क्या लिखा हुआ है? Majority function is generated in a combinational circuit when the output. Here we are going to talk about the output value. Here some kind of the hint is given in order to obtain the output value. What hint is that? When the output is equal to 1, a majority function, when the output is equal to 1, if the input variables have more ones than zeros. If in input variable more number of ones are there in comparison to number of zeros, more number of ones in comparison to number of zeros, it will generate the value of f as 1. आप इसे काउंट करो, यहाँ नंबर ऑफ वंस कितने हैं? 1 1 जहां पर आ रहा है, ये 1 1 आ रहा है, इस कॉम्बिनेशन में आओ, इसमें नंबर ऑफ वंस कितने हैं? 2 है. नंबर ऑफ जीरोस कितने हैं? 0 है. तो नंबर ऑफ वंस इज ग्रेटर देन नंबर ऑफ जीरोस. तो जहां पर भी नंबर ऑफ वंस इज ग्रेटर देन नंबर ऑफ जीरोस, इट विल जनरेट द आउटपुट वैल्यू एज 1. सिमिलरली, और 1 कहां पर आ रहा है? यहाँ आ रहा है. यहाँ भी देखो नंबर ऑफ वंस कितने हैं? 2 है. नंबर ऑफ जीरोस 1 है. तो नंबर ऑफ वंस इज ग्रेटर देन दैट ऑफ नंबर ऑफ जीरोस. तो आउटपुट क्या निकल के आएगा? 1. लेकिन आप स्टार्टिंग में देखो, स्टार्टिंग में देयर इज नो नंबर ऑफ वंस, तो नंबर ऑफ वंस इज 0. नंबर ऑफ जीरोस आपके हायर देन दैट ऑफ नंबर ऑफ वंस है, तो आपको फाइनल आउटपुट वैल्यू क्या होगी? 0. सेकंड कॉम्बिनेशन पे आए तो यहाँ नंबर ऑफ जीरोस ज्यादा है नंबर ऑफ वन से, तो नंबर ऑफ जीरोस ज्यादा है तो आपका आउटपुट क्या आएगा? 0 आएगा. यहाँ पर नंबर ऑफ जीरोस ज्यादा है नंबर ऑफ वन से, तो आपका क्या आएगा? आउटपुट 0 आएगा. या नंबर ऑफ वंस ज्यादा है नंबर ऑफ जीरो से, इसलिए आउटपुट 1 आएगा. नंबर ऑफ वंस इज लेस देन नंबर ऑफ जीरोस, नंबर ऑफ जीरोस ज्यादा है, इसलिए आपका एफ क्या आ रहा है? 0 आ रहा है. यहाँ नंबर ऑफ वंस ज्यादा है नंबर ऑफ जीरो से, अगेन वैल्यू विल बी 1. सिमिलरली नंबर ऑफ वंस कितने हैं? 2 है. नंबर ऑफ जीरोस क्या है? 0 है, 1 है. तो आपका नंबर ऑफ वंस ज्यादा है, इज ग्रेटर देन दैट ऑफ नंबर ऑफ जीरोस, तो आपकी वैल्यू क्या आएगी? 1 आएगी. यहाँ नंबर ऑफ वंस फिर क्या है आपके? ग्रेटर देन दैट ऑफ नंबर ऑफ जीरोस, तो एफ की वैल्यू क्या आ रही है? एफ आ रही है. सो वंस यू हैव ऑब्टेन्ड द ट्रुथ टेबल, अब आपका फाइनल एग्जाम, बिकॉज आपका ओपन बुक एग्जाम होगा, ओपन बुक एग्जाम होगा तो ऑलवेज मे बी द पॉसिबिलिटी कि हमेशा यही वाला लॉजिक गिवन ना हो, यहाँ पे कुछ आपका चेंज कर दें. सो यू शुड बी अवेयर ऑफ कि आपको ट्रुथ टेबल कैसे बनानी है, इस टाइप से बनानी है. यहाँ जिस भी टाइप का आपका हिंट चेंज होगा, अकॉर्डिंगली ट्रुथ टेबल विल बी चेंज्ड. Once you have obtained the truth table, उसके बाद you have to apply the K map over F. आपने K map अप्लाई किया, फिर 2 और 4 का ग्रुप बनाया, 2 के ग्रुप बनाए, एक 2 का आपका वर्टिकली बना, एक हॉरिजॉन्टली बना, एक लेफ्ट साइड हॉरिजॉन्टली बना, and ultimately from the K map you are being able to obtain this expression. Once you are having expression with you, आप logic circuit diagram भी इसका draw कर सकते हैं very easily. Now we come to next question. क्या है आपका next question? Question number 16. डिजाइन अ कॉम्बिनेशनल सर्किट विद 3 इनपुट. अब फिर आपका एक नया हिंट गिवन है इन ऑर्डर टू ऑब्टेन योर ट्रुथ टेबल. सिमिलर काइंड ऑफ क्वेश्चन है. वंस यू ऑब्टेन द ट्रुथ टेबल, आपको के मैप लगाने हैं. के मैप लगा के आपको क्या करना है? बुलियन एक्सप्रेशन बनाने हैं. बुलियन एक्सप्रेशन के बाद यू हैव टू ऑब्टेन इट्स लॉजिक सर्किट डायग्राम. आई एम रीडिंग आउट द स्टेटमेंट. डिजाइन अ कॉम्बिनेशनल सर्किट विद 3 इनपुट्स. कौन कौन से हैं? एक्स वाई जेड एंड 3 आउटपुट्स ए बी सी. व्हेन द बाइनरी इनपुट इज 0 1 2 3, मतलब डेसिमल में अगर ये मिन टर्म ये आ रही हैं तो आउटपुट क्या निकल के आता है? द बाइनरी आउटपुट इज 1 ग्रेटर देन दैट ऑफ इनपुट. और अगर व्हेन जब बाइनरी इनपुट इज 4 5 6 7, मतलब इनपुट की मिन टर्म, इनपुट की वैल्यूज, डेसिमल वैल्यू ये निकल के आ रही हैं, तो बाइनरी आउटपुट क्या आ रहा है? बाइनरी आउटपुट इज 1 लेस देन दैट ऑफ इनपुट. मतलब फर्स्ट वाले केस में अगर मिन टर्म की वैल्यू 0 1 2 3 है तो बाइनरी आउटपुट क्या होना चाहिए? बाइनरी आउटपुट मतलब 1 ग्रेटर देन द इनपुट. मतलब 0 था तो इसका आउटपुट 1 होगा, 1 था तो इसका आउटपुट 2 होगा, 2 वाली मिन टर्म है तो इसका आउटपुट 3 होगा, 3 वाली मिन टर्म का आउटपुट 4 होगा. सिमिलरली दूसरी वाली लाइन क्या कह रही है कि बाइनरी इनपुट अगर 4 5 6 7 है तो बाइनरी आउटपुट क्या होगा? 1 लेस देन, 1 कम होगा, लेस देन द इनपुट. और इनपुट क्या थे? 4 5 6 7. मतलब 4 वाली मिन टर्म है तो ये आउटपुट क्या डिराइव करेगी? 3 करेगी. 5 वाली मिन टर्म आउटपुट क्या जनरेट करेगी? 4 करेगी, 1 लेस करेगी. 6 वाली मिन टर्म 1 लेस आउटपुट जनरेट करेगी, मतलब 5. 7 वाली मिन टर्म आपकी 1 लेस आउटपुट जनरेट करेगी, दैट मीन्स 6 करेगी. नाउ वी कम टू इट्स ट्रुथ टेबल इन टर्म्स ऑफ बाइनरी फॉर्म. देखो कैसे ड्रॉ करनी है आपने ट्रुथ टेबल. वी कम टू क्वेश्चन नंबर 16. ये आपने एक्स वाई जेड 3 कॉम्बिनेशन है, सारे पॉसिबल कॉम्बिनेशन ले लिए और आउटपुट आपके यहाँ पर 3 है, ए बी सी. ए बी सी मतलब आप देखिए अगर आप डेसिमल में बात करें, डेसिमल में 3 बिट में बात करें, दैट्स वाई हमने ये बाइनरी में लिए कि डेसिमल में, क्योंकि आपका आउटपुट जो एज पर द गिवन क्वेश्चन आपका जो है कि क्या है कि आउटपुट क्या आ रहा है आपका? 1 लेस या 1 ग्रेटर, 1 लेस या 1 ग्रेटर देन दैट ऑफ इनपुट वैल्यू. तो आपने यहाँ आउटपुट भी 3 ही लिया आपके. ए बी सी मीन्स अब यहाँ पर आओ 0 0 0, 0 की डेसिमल वैल्यू क्या होती है? 0 होती है. तो 0 1 2 और 3 के केस में क्या था? 0 1 2 और 3 के केस में जो आउटपुट निकल के आया था दैट वाज 1 ग्रेटर देन दैट ऑफ इनपुट वैल्यू. वो +1 करते चला जाओ तो वो आपका आउटपुट बन जाता था. अब +1 करो इसमें, मतलब अगर ये 0 है तो आउटपुट क्या होगा? 1 होगा. और 1 की बाइनरी वैल्यू क्या है? 0 0 1. और ये 1 है और डेसिमल में ये 1 है तो इसमें आउटपुट क्या होगा? +1. दैट मीन्स 2 हो जाएगा. ये 1 है तो ये 2 होगा, ये 2 है तो ये 3 होगा, ये 3 है तो ये 4 होगा. लेकिन जो फर्दर वाली मिन टर्म्स है 4 5 6 7, इन केस में 1 लेस होगा आपका आउटपुट. मीन्स अगर ये 4 था तो ये 3 होगा, ये 5 था तो ये 4 होगा, ये 6 था तो ये 5 होगा. और 7 के लिए नहीं लिखा, 7 के लिए इट विल बी सेम. नहीं, 7 के लिए भी आपका लेस होगा. और 7 द बाइनरी आउटपुट इज 1 लेस देन द इनपुट. उसमें देयर इज अ मिस्टेक. 7 के लिए वो 6 होगा. 7 के लिए इट विल बी 1 1 0. वंस यू हैव ऑब्टेन्ड दिस टेबल you have to go in a similar manner. Similar manner मतलब अब आपके आउटपुट 3 है, A B C. A पे भी K मैप लगाएंगे, B पे भी K मैप लगाएंगे, C पे भी K मैप लगाएंगे. 3 separate K मैप बनेंगे and afterwards you will get, इसमें से 2 K मैप्स है but you have to have the 3 K maps. Afterwards you will obtain 3 expressions. और 3 expressions के लिए इन्होंने लॉजिक सर्किट डायग्राम नहीं बनाया because it would have become very much complex diagram. ये आपका यस मिस
मैम ये वाला क्वेश्चन मैम हमने सॉल्व किया था तो मुझे नोटिस करने पे ऐसा लग रहा है कि जो मैम ए वाला कॉलम है एंड बी वाला कॉलम है ना, तो ए वाला तो कैपिट है एंड बी जो है वो सम वाला कॉलम है. बट मैम
ए क्या है? ए क्या है?
ए मैम कैरी बिट शायद रिप्रेजेंट कर रहा है, मतलब ऐसे देखने से.
यस, तो तभी इसे फुल एडर का है ना. देखो दैट्स व्हाई इट इज बीइंग कॉल्ड एज.
रोल ही नहीं है ना, तो हम वो बनाएंगे कैसे फिर सर्किट डायग्राम?
एक मिनट होल्ड ऑन. किसका रोल नहीं है?
मैम सी वाले कॉलम का.
सी आपका कैरी है ना, एस आपका सम है.
ए कैरी है, बी सम कॉलम है एंड मैम सी एक्स्ट्रा है.
जस्ट होल्ड. सी आपका क्या है? सी इज इक्वल टू जेड डैश. ये थर्ड वाले एक्सप्रेशन से निकल के आया है. ओके तो ये क्या कह रहे हैं कि इतना वाला पोर्शन आपका फुल एडर का काम कर रहा है. एक एक्सटर्नल आउटपुट भी निकल के आ रहा है जिसे हम सी इज इक्वल टू जेड डैश कह रहे हैं. तो जितना है तो इट इज फुल एडर प्लस वन मोर एक्सटर्नल आउटपुट.
मैम तो हमें ये ब्लॉक डायग्राम ही बनाना है, मतलब वो जो सर्किट डायग्राम है और गेट्स यूज करके वो नहीं बनाना.
जस्ट होल्ड ऑन, वो इट ऑल विल डिपेंड ऑन द गिवन क्वेश्चन। क्या आपको एग्जाम में अगर आपको लॉजिक सर्किट डायग्राम पूछा जाता है तो वो पूरा वाला बनाना है, अगर आपको ब्लॉक डायग्राम पूछा जाता है तो ये वेग वाला बनाना है।
मैम उन्होंने कॉम्बिनेशनल सर्किट डायग्राम लिखा है क्वेश्चन में।
वैसे बनाना है, बाय रूल बनाना है, दोनों बना देना।
दोनों।
ओके
यस
ओके,
मैम।
तो ओ पे अलग से
ओके।
के मैप लगाया, बी पे लगाया, सी पे लगाया, तो यू गॉट दीज थ्री काइंड ऑफ द एक्सप्रेशन। एक आपको ये एक्सप्रेशन मिला, एक ये मिला, और एक ये सी इज इक्वल टू जेड डैश। तीनों को कंबाइन करके अल्टीमेटली ऑब्टेनिंग फुल एडर डायग्राम प्लस वन एक्सटर्नल आउटपुट, जो क्या है, सी विल बी इक्वल टू जेड डैश। नाउ वी
ओके
कम टू
मैम।
द नेक्स्ट क्वेश्चन, क्वेश्चन नंबर 17। Show that a JK flip-flop can be converted to a D flip-flop with an inverter between the J and K inputs. I told you कि JK या SR के बीच वाली टू रो को यूज करते हुए आप D flip-flop को बना सकते हैं। तो कैसे बना सकते हैं? ऐसे बना सकते हैं, बाय दिस डायग्राम। सिमिलरली इन एग्जाम्स इट में भी आज कि आपका टी फ्लिप फ्लॉप कैसे बनाया जा सकता है, तो वो अपने से प्रैक्टिस कर लेना कि एस आर जे के फ्लिप फ्लॉप की फर्स्ट वाली और लास्ट वाली रो को यूज करते हुए एस आर को टी फ्लिप फ्लॉप कैसे एक्सट्रैक्ट कर सकते हैं। कि डी
मैम
को यस प्लीज।
मैम इनके सर्किट डायग्राम जो जैसे आपने कल दिखाए थे पीपीटी में वैसे तो नहीं बनाने हैं ना, लाइक सिंपल ब्लॉक डायग्राम जैसे बुक में दिए हुए हैं।
यू आर टॉकिंग इन टर्म्स ऑफ क्वेश्चन नंबर 17, कौन सा क्वेश्चन की बात कर रहे हैं?
यस मैम, इन द टर्म्स ऑफ 17।
ठीक है, ये देख लेते हैं हम। ऐसा बनाना है क्वेश्चन नंबर 17। ये आपका ब्लॉक डायग्राम ही है, काइंड ऑफ अ ब्लॉक डायग्राम। ये क्या कह रहे हैं?
एक्सप्लेन SR flip flop by a complete circuit diagram, so that's why I was asking.
बेटा कौन सा वाला, किस कंटेक्स्ट में पूछ रहे हो?
Ma'am, I got it. Ma'am, वो circuit diagram.
ठीक है, नाउ वी आर टॉकिंग इन टर्म्स ऑफ क्वेश्चन नंबर 17। क्वेश्चन नंबर 17 क्या कह रहे हैं? क्वेश्चन नंबर 17 सेज दैट कि आपको शो दैट जेके फ्लिप फ्लॉप आपको गिवन है, कैन बी कन्वर्टेड टू अ डी फ्लिप फ्लॉप है, उसे कैसे कन्वर्ट कर सकते हैं अगर एक इन्वर्टर गेट को यूज किया जाए इन बिटवीन जे और के के बीच में। जे और के के बीच में अगर एक इन्वर्टर गेट को लगा दिया जाए तो इट विल वर्क एज डी फ्लिप फ्लॉप। एक जे इनपुट गया, के इनपुट गया।
मैम इन्वर्टर का मतलब मैम कि हम जे का मान लीजिए जीरो इनपुट है तो हम उसे 1 इनपुट देंगे पहले।
बेटा एक मिनट, जस्ट होल्ड, लेट मी कंप्लीट एंड देन यू आस्क द क्वेश्चन। ओके,
Okay,
लेट मी
ma'am.
एक्सप्लेन दिस आंसर एंड देन यू कैन आस्क।
ओके मैम।
तो जे और के अगर आपके इनपुट है जेके फ्लिप फ्लॉप में, अगर हार्डवेयर इंजीनियर्स के पास एक जेके फ्लिप फ्लॉप पड़ा है और एक इन्वर्टर पड़ा है, तो इन दोनों को कंबाइन करके उसका अल्टीमेटली जो फंक्शन है उसे कोई डी फ्लिप फ्लॉप को कहीं यूज करना है, सो ही कैन कस्टमाइज दिस जेके फ्लिप फ्लॉप टू वर्क एज योर डी फ्लिप फ्लॉप। अब डी फ्लिप फ्लॉप का क्या फीचर है कि एक सिंगल इनपुट रिक्वायर्ड है और सिंगल आउटपुट देगा, जो इनपुट गया वही आउटपुट निकल के आएगा। लेकिन जेके फ्लिप फ्लॉप दो इनपुट को यूज कर रहा है। तो अगर इस वे में अगर इसे कंबाइन किया जाए, कैसे किया जाए कि एक डी की लाइन हम जे वाले को डी कह रहे हैं और इसका अगर इन्वर्टर कहें तो के के अंदर जो इनपुट गई उसकी इन्वर्टेड वैल्यू गई जो डी की गई। अब देखो जे के फ्लिप फ्लॉप क्या कहता है, पहले हम जे का इनपुट डाल के देखते हैं। जे की वैल्यू मतलब बेसिकली हमें क्या निकालना है कि डी के अंदर जो वैल्यू जाए, क्यू की वैल्यू जो फाइनल निकल के वही की वही आए जो कि इनपुट गया था। जे यही कहता है ना, जो इनपुट गया वही आउटपुट निकल के आना चाहिए। अगर ये फुलफिल कर देता है इस कंडीशन को, देन विल से कि डी फ्लिप फ्लॉप का काम कर रहा है। तो अब हम बाय ऑब्जर्वेशन देखते हैं कि इनपुट डालते हैं, क्या ये डी फ्लिप फ्लॉप में जो हम इनपुट डाल रहे हैं वही आउटपुट निकल के आ रहा है कि नहीं आ रहा। तो फर्स्ट में हमने डी की वैल्यू 0 डाली और सेकेंड टाइम में हमने डी की वैल्यू 1 डाली। अब जब डी की वैल्यू 0 डाली, देन वी आर ऑब्जर्विंग कि आउटपुट क्या निकल के आ रहा है। अब देखो जब डी की वैल्यू 0 डाली तो इंटरनली उसे जेके फ्लिप फ्लॉप मिला। अब वो जेके फ्लिप फ्लॉप तो अपनी कैरेक्टरिस्टिक टेबल के अकॉर्डिंग बिहेव करेगा, तो डी की वैल्यू जे में गई और इसकी इन्वर्टेड वैल्यू 1 जो गई के में गई। तो आपका कौन सा कॉम्बिनेशन मिला? 1 0। अब 1 0 आप जेके के फ्लिप फ्लॉप पे जाओ, टेबल पे जाओ, 1 0 वाला कॉम्बिनेशन क्या कहता है? अगर 1 0 जेके का कॉम्बिनेशन मिले तो आपकी कैरेक्टरिस्टिक टेबल ऑफ जेके क्या कहती है कि 1 0 के अगेंस्ट आउटपुट की वैल्यू क्या आनी चाहिए? यू गो बैक टू द टेबल ऑफ योर जेके फ्लिप फ्लॉप। तो क्या कहता है ये जेके फ्लिप फ्लॉप, क्या कहता है कि अगर 1 0 मिले तो आउटपुट हमेशा 1 ही निकल के आएगा। सी, आउटपुट हमेशा 1 निकल के आएगा। तो जे की वैल्यू, एक just hold on, just hold on. J की sorry, it is 0 1, sorry, it is 0 1, 0 J की वैल्यू 0 गई, K की वैल्यू 1, मतलब 0 1 आया तो 0 1 के केस में ऑलवेज आपका आउटपुट 0 निकल के आएगा एज पर द टेबल। 0 1 के केस में आउटपुट हमेशा 0 निकल के आएगा और 1 0 के केस में आउटपुट हमेशा 1 निकल के आएगा। सो 0 1 के केस में एज पर द कैरेक्टरिस्टिक टेबल ऑफ जे के आउटपुट क्या निकल के आएगा, 0 निकल के आएगा। फाइन, तो इसका मतलब पहले वाली कंडीशन फुलफिल हो रही है। अगर डी को 0 डाला तो आउटपुट भी 0 निकल के आ रहा है। अब दूसरे केस में चेक करो, डी की वैल्यू 1 डालो, डी की वैल्यू जब 1 डाली तो जे की वैल्यू 1 हो गई, लेकिन के की वैल्यू 0 हो गई, उसकी इन्वर्टेड वैल्यू हो गई। तो 1 0 के केस में जेके की कैरेक्टरिस्टिक टेबल क्या कह रही है, जब जेके की वैल्यू 1 0 है तो आउटपुट हमेशा 1 निकल के आएगा। सो दैट मीन्स इनपुट डी की वैल्यू जे 1 गई और आउटपुट भी 1 निकल के आ रहा है। सो दैट मीन्स इट्स गोइंग टू फुलफिल the functionality of D flip-flop. Now we can say that it is working as if the D flip-flop is working. So this way, JK flip-flop may be customized to work as D flip-flop provided one inverter gate is being used with JK flip-flop. Is that clear now? Similarly, आप D flip-flop का खुद से बना के प्रैक्टिस करेंगे. It may come in the exams. Now we come to the
yes ma'am, clear.
Now we come to the next last question. Question number 18. Using the information from the characteristic table of JK flip-flop listed in figure in the above table, already we have discussed. Derive the excitation table for the JK flip-flop and compare your answer. It's the same thing we already have solved. मतलब आपको JK flip-flop की characteristic table से excitation table को derive करना है. That we already have done with, and it's a solved part of your chapter. Okay, so this way a question may come up in your exam. So till question number 18, you have to solve all the questions. Those are based on all the contents covered up in your chapter as per your course contents. आपका जो question number 19 onwards है, those are based on your section 1.7 के वो आपका portion आपकी guidelines और आपके course में नहीं है. That's why we are ending this chapter here only, and I'm switching to the attendance part now. Are you having any kind of the doubts? Let me know, please.
Yes, ma'am. Ma'am, I want to ask, अगर हमें sequential circuit का example देना होगा तो हम क्या देंगे?
Simply you mention binary counter. I am not
Ma'am,
doing it.
करना होगा.
Binary counter generates the है, क्या कह रहे हैं आप?
Ma'am, explain नहीं करना होगा उसे.
देखो बेटा, अगर आपको explain करना है, I already have sent you the slides जिसमें मैंने ये सब hidden form में आपको already I have provided you in the hidden form. You can unhide all these slides और unhide करके ये थोड़ा थोड़ा you can go to the brief concepts. Otherwise it will not be asked once it is not in your syllabus.
Okay, ma'am.
ये सारा का सारा are already expressed on in all these slides, because earlier it used to be there in your course, but your course was becoming very much complex. So in order to reduce the complexity, कुछ portion last year deduct हुआ था आपका, ये portion आपका exclude किया गया था, as you are the first year students only.
Can you once again tell us that which part of the chapter is cut from?
आपका till you have to go by the guidelines. I already have provided you the guidelines. Again, I am showing you the copy of the guidelines. Let me show you again. I will provide you on your WhatsApp group as well if you want the copy of the guidelines. And let me show you guidelines. These are your guidelines. You have to go by the guidelines only. Just hold on. Just hold on.